Okay, now let's see if you can test your hypothesis of inheritance. Okay, so the students say, if I give you a tall plant and asked you to tell me what factors or alleles it carried, in other words, what is the genotype of a plant? All you know about it is that it is tall. How would you go about determining what its genotype is? That means, what are the two alleles that contribute to its being tall? Okay. Are any of these choices the right choices to follow to determine the genotype of a plant? Think about it. Well, this is what Gregor Mendel did. If the unknown plant is tall, it must be either two T's, capital T's, or a capital T and a short t. That means it is either homozygous dominant or it is heterozygous. If I breed it with a short plant, which is recessive, homozygous recessive, what are the predicted outcomes? This is how Mendel questions himself. And then he carries out the experiment based on that question and he looks at the results. Okay. What do you think the predicted outcomes from this experiment will be? Think about this, pause the video, write down the answers, and then move on. Here's what I did again. If the unknown plant is tall, it must be either homozygous dominant or heterozygous. If I breed it with a short plant, recessive, then here are the possibilities. Okay, so I'm doing a cross with which might look like this in the parental generation or like this in the parental generation, depending upon whether your unknown tall plant has this genotype or this genotype. This is what you're trying to determine. Is it this or this? Now, Leo, suppose the results were 57 tall and 43 short. What would you conclude? I'd say this result represents an equal distribution of tall and short. Okay? It's not exactly equal, but it never is in a real experiment. It's never exactly what you think it's going to be. Okay? So you have to approximate this to 50 and then approximate this to 50 and say, well, so the results show that there's an equal distribution of tall and short. Okay, so can you conclude the genotype of that unknown tall plant based on this observation? Think about it. Gregor Mendel could make a conclusion. So you will be able to too. So take a minute and think about that and then move on. What Gregor Mendel concluded was, yes, the unknown was heterozygous for height. That means one capital T and one small t. Gregor Mendel opened his eyes and saw Leo quietly putting coal on the fire. The monk reached over to his old cold cigar. Holding it to a candle, he lit it, puffing deeply. He knew it was bad for his heart, his kidneys, his everything. A disgusting habit, he thought. He reached for his old notes and paged along. Gregor Mendel knew he was dying. He had a good life. He communicated with scientists and worshipped with God. Even now, in his latter years, when the business of the abbey was so irritating, he still had his music and chess and his cigars. Always his 20 cigars a day, a small vice that God would forgive. He no longer could breed mice, for they escaped too often and stunk too much. But he had his honeybees and his meteorological reports, his records. He always kept meticulous records. Records were essential, otherwise his bee experiments would have been impossible. How else could he have been able to keep track of 2 traits or more when he was breeding? He found the section in his notes called Dihybrid crosses, where he analyzed 2 traits at the same time. Given that he wanted to breed a pure round yellow seed plant, both were dominant traits, with a pure wrinkled green seed, both were recessive traits, he decided that he would write it this way. 2 capital R's, 2 capital Y's, representing the dominant breed, crossed with 2 small r's and 2 small y's, representing the recessive traits. This is a dihybrid cross. Okay? The seed shape is either round or wrinkled, represented by the letter capital R or small r, representing dominant or recessive, respectively. The seed color is yellow or green, represented by capital Y and small y, respectively. So in the parental generation, this is what the genotype appears when you cross it. What do you expect the familial F1 generation to be? So think about this, genotype and phenotype, and we'll continue talking about dihybrid crosses in our next video recording.